Hello, this is an introductory video for my logic class. We are going to cover some of the main concepts from chapter 1, and then I'll have a follow-up video working through the homework, which is mostly multiple choice type questions and example questions testing these concepts. Okay, so I'm going to try and get to the heart of the main concepts so then we can work those exercises and I can give further explanations that way. Okay, this logic class uses the text, the Hardegree text. It is a course on what we call deductive logic. Okay, it is logic and arguments, reasoning, where the conclusion of the reasoning is, as we'll see, forced by the premises. Okay, that's deductive reasoning. All right, so it's not that most of the time when I go to the store they have milk. I'm going to the store, so they'll probably have milk. That's probable reasoning. That's a different kind of reasoning. This is what we call deductive reasoning. Okay, so we're going to give you the main concepts to help see that. I think the best thing to do is to start by example. Okay, here's a series of statements. The statements, which are sentences that make truth claims. We can mark them as true or false. In this class, we're not going to be too worried about what makes something true, those kinds of questions. Grass is green, that's true. Grass is orange, that's false. Both of those are statements. Okay? All right, so let's look at this series of statements, and they're put together in a certain way. All cats are mammals. All cats are mammals is the first statement. Cleo is a cat. Cleo is a cat. Cleo's my cat. So, now here's the thing. You already know how to do deductive logic. You can logically, what we'll call deductively, draw the conclusion from these statements. All cats are mammals. Cleo is a cat. So, Cleo is a mammal. Okay. Now, I told you that Cleo is my cat. So this statement is true, and this statement is true. Okay. But what's actually key to this is that the connection between these statements. If I never told you anything about Cleo, you could still see that this is what we might call in ordinary speech a logical argument. It makes sense. If you make these two statements, all cats are mammals and Cleo is a cat, they are both true statements, you have to make this statement. Okay? So deduction is where the conclusion is, so to speak, forced by the premises. If you state the premises, you're logically committed to the conclusion, and we'll give you another term for that to help understand that. Okay? Let's compare that to another argument. All cats are mammals, true. Hazel is a mammal. Hazel is my puppy. So that's true. That's a true statement. That's a true statement. But suppose we concluded, since all cats are mammals and Hazel is a mammal, suppose we said therefore, and it's this therefore, right, that is drawing a conclusion from other statements. Therefore, Hazel is a cat. Tempting, right? All cats are mammals. Hazel is a mammal. If we're being hasty, we might say, oh, so Hazel's a cat. Okay? I play a game with my kids called Outfoxed. It's a cooperative game. It's like Clue. So you get clues. You have certain suspects. They're all foxes. They've stolen some eggs from a chicken coop, right? And all the foxes have certain distinguishing characteristics, right? A hat, a cape, those kinds of things. And so as you get clues, you find out, does the thief have a cape or not have a cape? Have an umbrella, not have an umbrella, okay? We can be hasty in those kinds of situations. We might say, oh, the thief has an umbrella, And Mary here has an umbrella, so Mary's the thief. But that is not correct. That is not correct reasoning. Right? And something similar goes wrong here. Just because all cats are mammals and Hazel is a mammal does not force the conclusion that Hazel is a cat. And in fact, in this case, that's false. Hazel is not a cat. Hazel is a dog. Okay? Not a cat. So, there's a difference between this argument and this argument. This argument, the key difference here is that this argument is what we'll call valid. Now, you're going to have to learn how we use the term valid, because in ordinary speech we use it in a slightly different way. This argument is valid in that the conclusion flows from the premises, and I'll let you know. I'll talk more about what I mean by flows from the premises, right? But I gave these examples to say, I gave you these statements, you were able to draw the conclusion, the forced conclusion, right? An argument that's put together that way with a forced conclusion is valid. This, where just because the premises are true doesn't mean the conclusion is true, that is invalid. Now we'll look at that more precisely. I'm just trying to introduce us to it. All right, let's look at the building blocks of these arguments. Each of these arguments is made up of statements. Okay? Made up of statements. There's not a specific number of statements that an argument has to have to be an argument. What is key is that, as I alluded to, you have one or more statements and then a conclusion that's drawn from those statements. That's inference. That's inferred from those statements. Okay? These two statements are set up to lead to this conclusion that Cleo is a mammal. All cats are mammals, Cleo's a cat, so Cleo's a mammal. All three of these sentences are statements. So the components of arguments are statements. But we have statements that have two different jobs. We have some statements that are used to support the conclusion as the basis for the conclusion. And then we have the conclusion that is drawn or inferred from those premises, from those statements. These statements, in this argument, we call premises. And the conclusion of the argument is the conclusion. We call the conclusion. Okay? So, arguments are made up of statements. One of those statements is the conclusion from the other statements. And those other statements we call premises, the premises of your argument, right? And this setup shows how that works. I'm asserting this, and on the basis of these two statements, I'm concluding this. Premise, premise, conclusion. Now, the statement Cleo is a cat, different statements can be premises in some arguments, conclusions in others. You can make those statements without making any argument. You can just say them, right? Cleo's a cat. I'm not making any argument. I'm just asserting that Cleo's a cat, right? But Cleo's a cat could be the conclusion of an argument. All the small pets in my house are cats, and Cleo is a small pet in my house, so Cleo is a cat. That would be a valid argument, and it is an argument, and the key is the conclusion of that argument is that Cleo is a cat. So statements, or sometimes I'll call them propositional statements, because these state propositions, statements that could be true or false, right? So these statements are the building blocks of an argument, and you can put statements together in different arrangements of premise and conclusion to get different arguments. Okay, so statements are the building blocks of arguments. You have one statement of an argument, that's the conclusion from the other statements. We call those other statements premises. They're the basis for the conclusion. Now let's look at something. This argument is good, as we've said, valid, and this argument is invalid. Okay. All the premises in both arguments are true. This premise is true. This premise is true. This premise is true. This premise is true. This conclusion is true. This conclusion is false. But what's key about valid and invalid is the pattern of the argument. You'll notice there's kind of a formula here, right? All A is B, and Cleo, C, is also A, so Cleo must be a mammal. C is also B. There's a pattern, a formula. That's not the only pattern and formula. The point is, it doesn't actually, for valid arguments, to make an argument valid, the point is not that all the statements in it are true. That's not what's relevant. What makes it valid is the way that this conclusion naturally flows from these premises. And in this case, we're using a good pattern of reasoning, whereas this is a bad pattern of reasoning. This pattern of reasoning gets you into trouble, right? This pattern of reasoning is all A is B, right? All squares have four sides, right? Then this shape has four sides, right? With the sticker. Therefore, it's a square. No, that's bad reasoning. This shape has four sides, therefore it's a square. That is bad reasoning, right? That's all A is B. C is B, right? This shape has four sides, therefore it must be a square. No, that's bad reasoning. Okay. We'll work on this. We'll look at examples in other videos to pin this down. But look at these two arguments, right? Come back to these two arguments. All cats are mammals. Cleo's a cat, so Cleo is a mammal. Valid. Not only is the conclusion true, that's actually not the critical point. The critical point is that the conclusion flows from the premises. Whereas here, the conclusion does not flow from the premises, right? The conclusion does not flow from the premises. And not just because it's false, the point is you have not guaranteed the conclusion with these premises. If someone assumed these premises, all cats are mammals and Hazel is a mammal, that doesn't, just think intuitively, that does not prove that Hazel is a cat, right? If these are true, that all cats are mammals, and that is true, and Hazel is a mammal, that also is true, Hazel could be a cat, a dog, a horse, right? Any number of mammals, okay? So just because it's a mammal and all cats are mammals doesn't mean that Hazel's a cat. There's something wrong in the link between premise and conclusion. Okay. I think I'll stop here. So this will be our introduction to arguments. And I'll go a little further with this idea of valid and invalid arguments and this idea of a link between premise and conclusion.